All right, this is section 13, topic 2.
Oh,
I thought we was doing part 2.
Topic 2. It's called the unit circle part 2, so. Topic 1 was the unit circle part 1.
I don't understand that.
That's just how Algebra Nation names it. And the target. How do you find coordinates of the point of intersection of the unit circle at a given point? Example 1. Find the coordinates of the point of intersection of the unit circle and a 30-degree angle. And I'm going to draw a circle for each one of these, okay? So much easier if you have it pictured in front of you to understand what you're doing. Do you remember how many degrees a whole circle has in it?
180, no.
360. And then a semicircle has 180. What about a quarter of a circle? 90. And what about, so if we start over here at 0 degrees, right? Then we have 90 degrees. Semicircle would be 180 degrees. What about 3/4 of the way around? 270 degrees. And then all the way around? 360. All right, so my other class was getting confused on, okay, well, how do you know if you go counterclockwise or clockwise? If the degree measure they gave you is a positive angle, do you remember what your notes say?
positive is
Counter. It seems like it'd be clockwise, but it's opposite of that. It's counterclockwise. So we're going to go from 0, and we're going to go up, and we're just estimating where 30 degrees would be. Okay, I know all the way up here is 90. Halfway is 45. So I'm just going to estimate where that 30 degrees would be. And what the question asked me, it wants to know the ordered pair where that ray that I made intersected the circle. Okay? So to be able to find that ordered pair, we have to make a triangle to help us. And we're going to use those relationships between the special right triangles to help figure out what that ordered pair is. Okay? So what you do is, you are going to make a reference triangle. So you go to that point where it intersected and you draw a line straight down so that it hits the x-axis at a 90-degree angle. Okay? So if this angle is 30, that's my theta, and I know I just created the 90-degree angle, then how many degrees is the other triangle? 60. It's got to be 180 altogether, right? So what I like to do, especially because it kind of gets jumbled up, I like to take that triangle that I just made out of the circle and draw it bigger so I can have a little bit more room to write and think, especially when I'm just getting used to it. You're like, all right, well, now what do we do? Okay, remember we talked about the 30, 60, 90 triangle. And the shortest side, if we called that side S, so your shortest side is always directly across from the smallest angle. We know that the hypotenuse is twice as long as the shortest side. So the hypotenuse is 2S. And then that middle leg is the length of the short side times the square root of 3. All right, this was another part that was confusing my other class. We already know that the hypotenuse has a length of what? 1. So if the hypotenuse has a length of 1, could we solve and figure out what S is? If we know that 2S equals 1, what must S equal? Well, they always do it in fractions, so yeah, 0.5, but I'll write it as fraction. So I know that my short side is equal to 1/2. I know the hypotenuse is equal to 1. And the middle side would be S times the square root of 3. So 1/2 times the square root of 3. Remember, when you multiply fractions, numerator times numerator, so square root of 3 over denominator times denominator. So that middle leg is the square root of 3 over 2. Now I'm going to try and go back and write that on my graph. So the short side was 1/2. Hypotenuse is 1, already had that. The middle side, which is across from the 60-degree angle, is the square root of 3 over 2. So we just wrote in the previous lesson in topic 2 that your base is your x value. That's always going to be what's on the x-axis. So your x value is the square root of 3 over 2. And your y is going to be your height, the 1/2. So that ordered pair, I'll write it bigger, is the square root of 3 over 2, comma, 1/2. And when we are in the first quadrant, aren't the x values positive and the y values positive? Okay. So when we find these on the triangle, they're always going to be positive because they're distances, they're lengths of measure. That's always positive, right? But when we say what the ordered pair is, it could be negative. So we have to remember, all right, is my x negative? Is it positive? Is my y negative? Is it positive? That's the answer. Anybody have questions so far? All right, example 2. Find the coordinates of the point of intersection of the unit circle. Yes. What? I can't hear what you're saying.
She's the nurse.
She's not here today. You need to go to the main office? Yeah? Yeah, the nurse is out today and tomorrow. I can send you to the main office, but she's not here. Okay. You all right? Did you say, can they do anything in the main office? I don't think besides call home and get you to check out. But they can't give you medicine or anything like that. I don't think, unless you have some in the, like, up there. No, okay. Are you okay? Let me know if you need to go. Of the unit circle and a negative 60-degree angle. Guys, I'm recording this.
Oh,
Yeah. So this is a negative 60-degree angle. So are we going to go counterclockwise or clockwise? Clockwise. So if we started here, this is 0. If we went all the way to this point, that would be at negative 90 degrees, right? But we're just going 60 degrees, so maybe approximately here. Now, you still call that a 60-degree angle. Angle measurements aren't negative. That just tells you where your rotation is going, okay? And so from that point of intersection, that's the ordered pair that I want to find. I want to find that ordered pair. From the point of intersection, draw a line, never to the y-axis, never to the y-axis. It's always to the x-axis, okay? So if my theta is 60 degrees, that's the angle formed by the origin. I just drew the 90-degree angle. Now the 30-degree angle is going to be down here, right? So again, it's not that you have to take it out of the triangle. Out of the circle, but it's just helpful to me to kind of enlarge it a little. So now my shorter side, it's always directly across from the 90-degree angle. We know the hypotenuse is twice as long as the short side, and then the side directly across from the 60-degree angle is s times the square root of 3. Well, didn't I already find these values in the problem above? If the length of the hypotenuse is 1, then what must s be? 1/2. And then s square root of 3, we found that that was equal to the square root of 3 over 2, right? So the lengths are the same. It's just kind of like the positioning, because it depends on where you draw.
So, Miss, you're taking the denominator from what x equals and just putting it under where,
Well, how did I find square root of 3 over 2? Is that what you're saying? Okay, so above, we found that s was 1/2, right? So the middle side is whatever the small side is times the square root of 3. So the small side was 1/2. Multiply that by the square root of 3. I made it a fraction by putting it over a 1. When you multiply fractions, numerator times numerator, that's how I got that. Denominator times denominator, that's how I got that. Okay? So I just multiplied those two together. That's all I did. All right, so now I'm going to take these and I'm going to transfer them back in. So my small side is 1/2. Hypotenuse is 1, of course. And the leg across from the 60-degree angle is the square root of 3 over 2. So your x values are going to be the base. Okay, what's the distance from here to here on the x-axis? Is 1/2. And do x values in this quadrant, are they positive or negative? This side of the x-axis, is it positive x's or negative x's? Right, so x is positive. Your y value is going to be the height, which is square root of 3 over 2. And y values in this quadrant, which we get them from the y-axis, right? Is that positive or negative? Negative. So my answer is 1/2, comma, negative square root of 3 over 2. Julio? Questions on that? So this whole rest of the notes, the rest of my examples, we're just going to keep doing the same thing. Okay? And you'll get the hang of it. Next we have, it's going to make a 45, 45, 90 though. We haven't done one of those. All right, example 3. Again, if you need my notes afterwards, you're welcome to come get them. And trust me, the more you want practice on this, because to get through trigonometry, you have to get this down and know exactly what you're doing. So the more practice that we have, the better. Find the coordinates of the point of intersection of the unit circle and a 45-degree angle. So my angle's positive. Are we gonna go clockwise or counterclockwise? Counter. So we always start at 0 degrees, right? We go up 45 degrees, that's gonna be halfway to 90. So to figure out this ordered pair where the ray that I drew, my terminal side meets the circle, I'm gonna have to make a triangle, right? So go to that point of intersection, draw a line straight down so that it hits the x-axis at a perpendicular angle. We know perpendicular means 90-degree angle, right? So if this angle, my theta is 45, then the other angle is 45. Remember, the theta, what you're finding the sine and cosine of, or the x and the y values, are of the theta. Whatever the angle is, it's formed at the origin. So we know that 45, 45, 90s, the two sides are equal, the sides that are opposite of the 45-degree angles, and we'll call those side S. And we know that the hypotenuse, if you take the length of side S and multiply it by the square root of 2, that will give you the length of the hypotenuse. Well, we also know that in a unit circle, the hypotenuse, which is formed by the radius, right? The length is always 1 in a unit circle. Not in every triangle. Every triangle has its own. The hypotenuse can be a different measurement, but in a unit circle, the hypotenuse of every triangle is 1. So we already know that the hypotenuse is 1. So since I know what that leg's equal to, I can solve for S, right? Because I know that S square root of 2 is equal to 1. I have to get S by itself. So since S is being multiplied by the square root of 2, and I want to get S by itself, can't I divide by the square root of 2? So that leaves me with S equals 1 divided by the square root of 2. We've only talked about this a little bit this year. You cannot have a radical in the denominator of a fraction. So to get rid of it, you have to rationalize the fraction. That means multiply your fraction by 1. But 1 comes in several forms, right? Isn't 5 divided by 5 1? Isn't a million divided by a million 1? So if I just multiply by the actual number 1, I'm going to get the same thing. I'm still going to have a radical in the denominator, right? Well, watch what happens if I multiply by the square root of 2 over the square root of 2. Isn't that the same thing as 1? Okay. When we multiply fractions, numerator times numerator, so 1 times the square root of 2 is the square root of 2. Denominator times denominator. What's the square root of 2 times the square root of 2? Is, what's 2 times 2? 4. So it's the square root of 4, and what's the square root of 4? 2. Did that get rid of my radical?
Yes.
Yeah, in the denominator. It's okay if it's in the numerator. So if I had square root of 3 in my denominator, I would multiply by the square root of 3 over the square root of 3. If I had the square root of 10 in the denominator, I would multiply by the square root of 10 over the square root of 10. Does that make sense? Okay, so the length of each leg is square root of 2 divided by 2, because that's what S is when we solve for S. So I'm going to go back over to my little right triangle. I know my hypotenuse is 1, and the length of each leg is square root of 2 over 2. So my base and my height are the same. Is either the x value or the y value, either or, are they negative in the first quadrant? No, they're both positive, right? So the ordered pair is square root of 2 over 2, comma, square root of 2 over 2. Example 4. Find the coordinates of the point of intersection. of the unit circle and a negative 30-degree angle. All right, negative 30 degrees. Are we going clockwise or counterclockwise? Clockwise. So we'll start at 0 and we'll just go down. We know this is 90, right? So not halfway through. It's between halfway and 0. That would be a 30-degree angle. So that's my theta. And then from the point of intersection, I will draw a line that forms a 90-degree angle. So now we might have done that 30, 60, 90 is enough that you already know what the legs are, right? Maybe. Let's see. We know the hypotenuse is what? 1. What's the length of the smallest leg right across from the 30-degree angle? 1/2. And what's the length of the middle leg? Square root of 3/2. Very good. So this ordered pair here, the x value is your base, right? The length of the base, and is that going to be positive or negative? X values on the right side is positive. And my y values down in this quadrant, are they positive or negative? So it's going to be negative what? 1/2. Once you know what those side lengths are of the 30, 60, 90 and the 45, 45, 90, then it's pretty easy because you don't do that math every time. It's always the same, right? You just have to know which leg, which angle is across from which leg, and you have to have all that correct. And then that's easy. Okay, well, now let me show you. The next two are just going to be a little different, and I need to show them before I give you your assignment, or you're going to be like, what? She didn't do any like that. I don't get it. All right, so example 5. So at this point, we've really only stayed in quadrant 1 and quadrant 4. Well, what happens when we're in quadrant 2 and 3? Find the coordinates of the point of intersection of the unit circle and a negative 120-degree angle. All right, so which way we headed? Clockwise, counterclockwise. Okay, so from 0 degrees to 90 degrees, it's going to be past that, right? It's 120 degrees. So how far past 90 do we need to go? How many more degrees do we need?
50.
We're only going to negative 120. 90 plus 50 would be 140.
30.
We need to go another 30 degrees, right? So from here to here, that's negative 120. Now, you can't have a right triangle that has 120 degrees in it. That's not even possible, okay? So this one's a little different because at that point of intersection, when we draw a line straight down so that it's perpendicular to the x-axis, we're actually going to use the other side of the angle to figure this out. The ordered pair is still the same, no matter if I use this angle or this angle. But I can't make a 120-degree triangle I'm sorry, I can't make a right triangle out of a 120 degree angle, you know what I'm saying? So if it's 120 degrees from here to here, how far is it from this terminal side all the way back to the x-axis? How many degrees are left? You know, how many degrees are in a straight line? 180. So we have 60 more to go, right? So wouldn't that create a 30, 60, 90? And our theta is the 60 degree angle, okay? We know the hypotenuse is 1, that's this side over here. What's the length of our smallest side? 1/2. And the side across from the 60 degree angle is square root of 3 over 2. Okay, now when this quadrant, you got to think about your negatives and your positives. Are your x's going to be positive or negative? Negative. And what about your y's? Negative as well, right? So what's your x value? It's the base. Negative 1/2. And your y value? Very good.
So wherever the base is at, that's where
The base is always whatever is the length on your x-axis. And then your y, so think about it. This distance from here to here, that would be where this is on your y-axis. Okay?
so whatever always touching the base will always be
Your x. Yep. And then the distance from the x-axis down to the point is your y, your height. All right, you think if we do one more, y'all will pretty much have a good idea of what's going on? Okay. Find the coordinates of a 150 degree angle. What quadrant is that angle going to be found in? Second. Remember, this is quadrant 1, 2, 3, 4. And it's positive, right? So we're going counterclockwise. So from here to here's 90. Somewhere between 90 and 180. Am I right? Okay. So we have to go, if we get 90, how many degrees past 90 do we need to go?
what is it, 150? 60?
Yeah, 60 degrees past 90. So from here to here is 150 degrees. Can you have a right angle that has a right triangle that has a 150 degree angle?
No.
No. So we're going to have to use the other side to help us figure out what this ordered pair is. As straight as I got. So what would be the measure of theta in this case? Can't use the 150. What's going to be the measure of the angle, the other angle we formed? 30, right? It's got to be 180 all the way to the line. You know what I'm saying? So that means this would be your 60. So we know our hypotenuse in any unit circle has a measure of 1. We know on a 30, 60, 90, the smallest side has a measure of 1/2. And then the middle side has a measure of square root of 3 over 2. So my x values in this quadrant, are they positive or negative?
For X?
Yeah. Negative. So it would be negative what? Got my base. My base. My base. My base. It's always what's on the x-axis. And my y values, are they going to be positive or negative?
Positive.
Positive. So that's my height, right? Which is 1/2.
So this one will be, I don't know.
bit complicated at first. Once you get it, you got it. It takes practice. Definitely takes practice, which is what you're getting ready to do as soon as I pause this video.
There's no, you ain't gonna throw no curveballs?
No,